welcome to this review for the Cytron Maker Pi RP2040. This board is a powerful robot controller that's perfect for building all sorts of robotic projects. Let's open the box and see what's inside. This board has a dual-core ARM Cortex M0 Plus processor, 264 kilobytes of internal RAM and 2 megabytes of flash memory. The same specifications as the Raspberry Pi Pico. However, what sets the board apart is its wide range of features and components, which make it a versatile and capable platform for robotics. So let's explore it a bit further. So let's start by taking a look at the features of the Cytron Maker Pi RP2040. The board comes with 4 servo motors connectors, 2 DC motors with quick test buttons, 2 for each one, and 13 status LED indicators. These ones here, you will see them when using the some sensors and the pins they are connected to, the LEDs will turn on. There's also a piezo buzzer here that we can mute using this small button here. 2 push buttons connected to pins 20 and 21, and 2 RGB LEDs, 0 and 1, for additional input and output capabilities. In addition, we also have 7 Groove input ports, including digital, analog, I2C, SPI, WART and several others, making it very easy to connect a wide range of sensors and other components to the board. It also comes with a very versatile power circuit that can automatically select power sources from the USB 5 volts, a LiPo cell or VIN from 3.6 to 6 volts. The board also comes with a built-in 1-cell LiPo Lion charger with overcharge and overcharge protection. Every time you have a LiPo battery connected here, if you power the board using USB, it automatically starts charging. And it also has an on-off switch we can use and to power the board. If we want to attach the board to some place, we have 4 mounting holes that we can use. It also comes with 4 rubber feet, but I've already connected them. And one thing that I love the most is for each groove connector we have here the schematics, the pin, if it's analog, digital, I2C, SPI, and for an added bonus, if we are using a LiPo battery, we can build a battery status indicator, so we can see the charge of the LiPo battery with the instructions that are in here. It's very good, this. And now that we have seen the features of the board, the board comes with CircuitPython, but I'm going to use MicroPython, so I'm going to show you now how to flash MicroPython on the board, and after that we're going to run several examples with the board that we are going to use for our final project. Hi everyone, so now let's start. I'm going to show you how to run MicroPython on the Cytron Maker Pi RP2040. First, let's connect the board, the power on. Okay, as you have seen, this is the code that comes with the CircuitPython. I'm going to open Tony, and here we have now. This is Adafruit CircuitPython. This is the code that starts when we connect the board, but this isn't what we want. And as you can see, we have here a new, when we connect the board using CircuitPython, we have a new drive here, but I'm going to use MicroPython, so let's give it a go. First we need to download MicroPython. So this is like an RP and Raspberry Pi Pico, so let's go for the RP2, and now let's gonna choose the board like the Pico, and we are going to get the latest version. Now we have here the firmware. To flash a new firmware on the board, we just turn it off, press the boot button, turn it on, release, and the new drive appears. Okay, so let's drag and drop the file there. The drive has disappeared. So now let's fire up Tony again, and now we have, okay, but I'd like to turn it off and turn it on again, and now we have MicroPython on the board. Let's run some examples. Hi, so now let's try the onboard buzzer. As you know, the board comes with a buzzer, this right here, and I have here a code to test it and to play a song. Per the documentation, the buzzer is connected to the pin 22, and then we next to make the buzzer a sound for the buzzer mix, we set the frequency. I have here 1000. The higher this number goes, the higher the pitch. You can hear it. I will set I will change this number so you can see the difference. And to set the volume, we just set the duty for the buzzer. I've seen from 15,000 above, don't really make any difference. And we just make a tone, and after a second we just set the duty to 0 and the buzzer stops. So let's try. Okay, I will try this. Okay, 5000, so you can hear the difference. See? So 1000, it's great. And the volume. Okay, again 5000, 1000. See, this is the volume. Now this is just a buzz. To play some music, we just play with notes. I have here a file from the internet that sets the note and the frequency. This is the same frequencies and same notes from the Arduino examples. This is just put in a dictionary, in the Python dictionary. And to play a song, we just have to know the notes and just play it in a function. I have here where I got this. Okay, now you see we are going to play Super Mario, and an example to play the music. So let's try this. Well, this is it. Playing a music, a song with MicroPython on the Cytron Maker Pi RP2040. So let's now try the DC motors. You know the board has two motor pins, so we can drive two motors, and it also has some quick test buttons to try the motors. We have nothing now connected, but we are going to use it. As you can see from the code, I've created a class to be much easier to drive the motors. Okay, how do I know? The class is already set for the pins definition for the board. The examples on the GitHub page set the frequency to 50, so this is how I'm going to go. And to set the speed, again we set the duty to that value. This can go from 0 to 65,535. So this is full speed. To stop, just set the value to 0. To turn left or right, just set one of the pins to the speed. One of the pins, each motor has two. One of the pins to the speed, the other one to 0, and this goes forward. And if we switch these, it goes backwards. And to turn left or right, just set one to forward, the other motor to backwards, and it turns left or right. So I've created this class. This is the code to use that uses the class and just uses the class functions to move forward, right, backward. To this test, I'm just going to connect one motor. This motor here from a hobby car, it's the same ones I'm going to use on the final robot car. So I'm going to put this on motor A. Doesn't matter which wire goes to which pin. Now it matters when you create the functions to turn left or right. If you program this one way, if you switch the wires, instead of going forward, it goes backwards. Now I have the motor here. So before we dive into the code, let's first test the quick test buttons. As you can see, it's working. Now let's try the code. Full speed, a little bit slower, and stop. See, it couldn't be easier. So now I'm going to test the servo pins, okay, that are here. We can connect up to 4 servos, but I'm going to try one of the more common ones, Tower Pro SG90, and I'm going also to use an MG996R. It's another common servo, but this one is a little bit stronger. Now I'm going to connect first the Tower Pro on the ShapeIO or pin 15. As you can see, the code is already here. I have 2 examples. One that uses the frequency, you set the frequency to turn the servo, and the other example, instead we use a function to calculate the angle, and instead of giving frequencies, we just give it the angle we want the servo to turn. So let's first try this one, the first example. Okay. Now, instead of that, I'm going just to give angles. Okay, stop. servo is not calibrated, but it doesn't matter. Just try to see. Okay, now this one is set. I believe this one that I have here is a continuous servo, so it doesn't stops at 118 degrees. It just keeps turning if you want. But yes, I'm pretty sure probably shouldn't be doing this with the board on, but let's go. Now, giving the angles. And now a continuous motion. As you can see, it works very well. Again, the frequency, it's on the GitHub page for the Cytron. This is from the examples, okay? And this is how we drive a servo with the board, using MicroPython. Hello again. Now I'm going to show you how we are going to drive a LED strip, or NeoPixel, or WB28 something dark side. We know the board has two onboard NeoPixels here and here, but I want to also use a strip. But because the board has no pins exposed, we need to use the groove connections. But the people from Cytron are great, and they offer 4 of these cables to connect to the groove inputs and use any sensor, or in this case a NeoPixel strip. So because on the code I have already the pin 26, I'm going to input this on the groove 5 input. Okay, I probably should be doing this with the board on. Okay, this is 5 volts. The ground. And because I have pin 26, it's the yellow cable, I'm going to connect this to signal, and now we have the strip connected. I'm going just to put it here so we can see. Now this example that I have here is taken straight from the MicroPython examples documentation. Okay, it connects to pin 26 and just executes some. I have already some functions here, but we are not going to use it. Just run the demo. I'm going to hold it here and run the demo again. As you can see, driving a NeoPixel strip, it's very easy. And now, last but not least, I'm going to show how to use a time of flight sensor. I did try to use ultrasonic sensor, but after a while I start to having some troubles. The program just wouldn't run and nothing was coming out of the sensor. And I've tried several. I've tried also several groove cables, and the problems just wouldn't go away. So I had a time of flight sensor lying around here and I decided to give it a go. I had to find this library from the internet. I have on the RoadTest page, I have all the links to this. Okay, this is this library is from GitHub, but I have the link on the RoadTest for the Cytron page. Okay, it's a bit, this file is a bit big, but this uses I2C communication. And let's connect the sensor. So this is VIN, ground, SDA is to pin 16, so this is going to use the groove for input. Acer pin GP16 is SDA, so SDA and 16 is the white, is going to here. LED for GP16 already it's on, and SCL it's to pin 17, it's the yellow one, so let's connect it here. Okay, now that we have it connected, let's try the example. The results will be in centimeters. Okay, like the hand, as you can see, it's probably 2 centimeters. Okay, this is giving the results in millimeters. Oh, the metric system. Let's see, this is working fine. This is to the oh, it's already detecting the camera. Oh, see, nice. And this is how we are going to use a time of flight sensor with MicroPython. Well, I'm out of examples to show you. Overall, I'm really impressed with the Cytron Maker Pi RP2040. It's a powerful and versatile board that's packed with features and components, making it a great choice for anyone looking to build a robot or any other project. The automatic power selection and built-in LiPo Lion charger is especially convenient, and the preloaded CircuitPython makes it easy to get started with programming right out of the box. Whether you're a beginner or an experienced maker, the Cytron Maker Pi RP2040 is definitely worth considering for your next robotics project.